and in the last class I given reactivity comparison also. Okay, aldehyde and ketone, which is more reactive towards nucleophilic addition, and what is the reason? Tell me. Aldehyde and ketone, which is more reactive. Why aldehyde is more reactive? Okay, then what happens if 1 plus I group is large positive charge? Yes, right. Let us continue chemical properties. Yesterday we started addition of sodium bisulfite. Right. No, I'll send. Yesterday I sent PDF. Now you follow that. Okay. NaHSO3. Once again I am revising. How to dissociate NaHSO3 H plus and SO3 Na minus, right? This is called adduct, sodium bisulfite addition gives adduct. A white color crystalline solid is called as adduct. Carbon is having positive, so this negative charge will add to positive. Oxygen is having negative, so positive adds to oxygen, will give adduct. Addition product called as adduct. Right. Now let us see limitations. Limitations are some specific points. All types of aldehydes react with sodium bisulfite. All types of aldehydes. All types of aldehydes react with NaHSO3, sodium bisulfite. Okay. Now coming to the ketones. What about ketones? Ketones with at least one alpha methyl. Ketones at least one. Ketones with at least one alpha methyl. Only react with the sodium bisulfite. React with the NaHSO3. Okay, means like this. This is alpha position, right? This is functional group. C double bond over functional group. This is alpha position. This is alpha methyl. So this ketone will react with the sodium bisulfite. Clear? Right. And here also one exceptional case is there. Even though acetophenone is having alpha methyl, it do not react. One exception. Actually, what I mentioned here, ketones with alpha methyl react with NaHSO3, but acetophenone, even though it is having alpha methyl, it do not react because of that bulkiness, steric crowding. Exceptional case. Note. Acetophenone, even though contains alpha methyl, do not react. Due to steric hindrance. Steric hindrance. Okay. Next property, addition of alcohol. See, alcohol adds to aldehyde or ketone in two different mediums, acidic medium and basic medium, and gives different products. Okay, let us see. Aldehyde or ketone I'm taking aldehyde or ketone and adding alcohol in acidic medium and adding alcohol in basic medium NaOH. Right, products are different. In acidic medium we will get acetal. What is acetal? I'll give you. Acetal is a compound in which one carbon is attached to two OR groups, two alkoxy groups. Look at this. The compound in which one carbon is attaches to two alkoxy groups, OR, OCH3, OCH2CH3, like that. That is called as acetal. Next, when alcohol react with the aldehyde or ketone in the presence of base, we get hemiacetal. What are hemiacetals? Hemiacetals are the compounds in which one carbon is connected to OR and OH, alkoxy group and alcohol group. Okay. Right, this is general information. Now let us see one example. Clear? Right. See the example. This is the aldehyde. I'm adding methanol. In presence of acid. Acidic medium. No. What I will get? I'll get acetal, OCH3 here and OCH3 here, OR. Acetal. Let us see the shortcut mechanism. How to write the product. Okay, mechanism, not original mechanism. This is shortcut mechanism. See, I am writing all here like this: RC double bond OH. In presence of acidic medium, 2 moles of alcohol addition takes place. Okay, you have to write 2 here, or you no need to write 2. But to remember how to write the product, so you can take 2 there, right? One alcohol I am writing like this: CH3 OH. Another alcohol, OHCH3. Okay, right? Now look at this, what I am doing. Here one hydrogen is there now. 2 hydrogens and 1 oxygen. I am removing hydrogen and oxygen. Water is eliminating, and this double bond will split and attaches to oxygen atoms. Very easy. Double bond is there now, that will split and attaches to oxygens to give that. Got it? Minus H2O. Clear? We are taking 2 alcohol molecules. We take 1 hydrogen from 1 alcohol, another hydrogen from another alcohol, and oxygen from aldehyde or ketone, and we remove all these. HAHO, H2O. So here CH3O remains, here also CH3O remains. So this double bond, look at this, just a second. See this. This double bond will split and attaches to oxygen. Clear? All of you. Are you following or not? Are you following or not? Right. Similarly, we can take one cyclic example, or ethane 1,2-diol. This is ketone. See, instead of taking two alcohol groups, what I am doing, I am taking ethane 1,2-diol. What is its name? Ethane 1,2-diol. Actually, in the last reaction, we took 2 alcohols. Right, now what we are doing, two alcohols means two OH groups should be present for the reaction. Okay, this is one OH and this is one OH. Why? Because from each OH H will come. H will come, and the two hydrogens combined with oxygen and water will be eliminated. That's why we need two OH groups. But in this case, the two OH groups are present in the same compound only. This is ethane 1,2-diol. What is its name? Ethane 1,2-diol. Diol. Ethane 1,2-diol. Look at this. This is the compound. Acetal. Acetal. See the mechanism here. You tell me what will happen. Guess what I'll do next. What I'll do? Removal of H2. Removal of H2. This double bond will split and attaches to oxygens. Yes. Minus H2. This is a very simple shortcut mechanism. Okay, right. And one important point I wanted to tell you. In the presence of acidic medium, we are getting acetal, right? We are getting acetal. But see, acetals are highly unstable. If we add water or if we add dilute acid, that will convert it to its parent compound. When I add dilute acid or if I do hydrolysis, that acetal will convert it to parent compound. Parent compound means starting what you took, you will get that only. Clear? Right. Very, very important. Acetals are unstable in water or in aqueous solutions. They converted back to carbonyl compounds. Clear? Actually, you will get acetal when you add alcohol in acidic medium. After that, if you add any small amount of water, that will convert it to parent compound, starting material. Clear? That is also important point. Okay. Right. Let us add alcohol in basic medium. Addition in basic medium. In the presence of basic medium, only one alcohol molecule addition takes place. See, CH3, C double bond OH. Addition in the basic medium. I am adding methanol, CH3OH in basic medium. In basic medium only one alcohol molecule addition takes place to produce hemiacetal. Hemi means half. OCH3. In the previous case, we got two OCH3 groups, right? Here only one OCH3. That's why it is hemi. Hemi means half. Hemiacetal. Hemiacetal. Okay, right. See the mechanism for it. Shortcut mechanism here also. Let us dissociate alcohol like this. CH3OH, right? Oxygen is having negative, hydrogen is having positive. The CH3O negative. That negative attaches to oxygen with negative attaches to carbon. This H plus attaches to oxygen. Just to split this into two parts. CH3O negative and H plus. Right. CH3, C, OH, OCH3 and H. Both are same only. Clear? Right. Did you get this? Right. Next. Addition of Grignard reagent. This is also nucleophilic addition example. Addition of Grignard reagent. What is the general formula of Grignard reagent? Tell me. What is the general formula of Grignard reagent? What is the general formula of Grignard reagent? RMgX. First chapter. It will dissociate into R minus and MgX plus. Grignard reagent dissociates into R minus and MgX plus. Let us see one example of Grignard reagent. CH3 MgCl. CH3 negative plus MgCl positive. This is dissociation of Grignard reagent. Okay. We did addition of Grignard reagent to carbonyl in the alcohol preparations, right? Look at this. I am taking aldehyde CH3C double bond OH and I am adding Grignard reagent methyl magnesium chloride. What is the negative part in Grignard reagent? What is the negative part? CH3 minus. In this is positive. This is positive, underlined. Okay, and you know in carbonyl group oxygen is negative, carbon is positive. Okay. CH3 negatively charged carbon attaches to carbon. Negatively charged carbon attaches to carbon. Both are carbons, right? MgCl. You know this reaction. Already we did in alcohols, right? Now what we will get? CH3CO MgCl CH3 and H. Okay, and you know what happens if we add water to this? What happens? You know already this reaction H2O. What happens? H and OH. Alcohol formation takes place. Bond will break. CH3COH alcohol. 2 degree alcohol is formed. Clear? Right. This is about Grignard reagent addition. Reactivity order is same. See, I given one generalized reaction, nucleophilic addition reaction of aldehyde, comparison of nucleophilic addition of aldehyde and ketone. You can apply same logic here also, which is having more positive means aldehyde and ketone, which is having more positive aldehyde only. So Grignard reagent readily adds to aldehyde. So aldehydes are more reactive towards Grignard reagent than ketone. Clear? And you know the concept. You know the concept behind it, right? Next category, addition followed by elimination reactions. Addition followed by elimination reactions. Addition followed by elimination reaction, right? First time adding ammonia. These are also very important category reactions. Addition of ammonia, NH3. Addition of ammonia. I am taking aldehyde RCH double bond O. See, during this category, addition followed by elimination, maintain oxygen at the end always. Maintain oxygen at the end, right? Next, ammonia can be written like this, NH3 can be written like this, H2NH, right? Okay. Now, eliminate water, remove water, minus H2O. What will be formed? Tell me. This double bond is as it is. Okay. R CH. This double bond is there now, and N will add here. Double bond NH. This is imine, very important. imine is formed. Imine. Carbon double bond NH. Imine. Okay. Got it? Are you getting both of you? Right. Addition of ammonia. Then what is the name of the product? Imine. Next, second one. Addition of primary amine RNH2. Addition of primary amine RNH2. You can add primary aliphatic or aromatic. Primary aliphatic or aromatic, but that should be primary aliphatic or primary aromatic. Now let us see. I am taking aldehyde. You can take ketone also, not only aldehyde, you can take ketone also, but you have to draw like this. Oxygen should be end, so that we can remove hydrogen and water easily, H2 and OH2O. If we write at the ends, we can combine and we can eliminate. Clear? Right. Okay. What I am taking? Primary amine, right? Remember the condition, how to write the reactants. Oxygen is at one end, hydrogen at the other end, same, means towards the same ends, right? So that we can remove water molecule. Remove water here, remove water. What we will get? RCH double bond NR, double bond NR. Okay, right. Just a second. Right. Look at this. What is the name of the product? Which amine we took here? Tell me. What is the degree of this amine? What is the degree of this amine? Tell me. Primary amine or not? Primary only, na? RNH2. Very important point. When we take primary amine, we'll get imine only, but that is specially called as Skipp's base. Very important. The imine formed is called as Skipp's base. And when you take primary amine, whether it is aliphatic or aromatic, in which of the following case the imine formed is called as Skipp's base? Very simple. Just see primary amine is given or not. If primary amine is given, then formed imine is called as Skipp's base. Got it? All of you. Right. Next, third one. Reaction with hydrazine. Reaction with hydrazine. You can take aldehyde or ketone, your wish. Hydrogen. What is the hydrogen formula? Hydrogen formula NH2, hydrazine. What is its name? Hydrazine. You remove water molecule. Minus H2O. Same. Mechanism is same. Removal of water molecule only. R CH double bond N NH2. Hydrazine will give hydrazone. Product name also important. Hydrazine, hydrazone. Clear? Right. Next. Reaction with phenyl hydrazine. Reaction with phenyl hydrazine. Reaction with phenyl hydrazine. See, take hydrazine and attach phenyl group, that is only phenyl hydrogen. I am taking this as it easily, but without one hydrogen. Here two hydrogens are there. I am taking only one hydrogen and I am attaching phenyl group. This is called phenyl hydrazine. Hydrazine or phenyl hydrazine? Phenyl hydrazine. Phenyl hydrazine. At this side aldehyde or ketone. Same mechanism. Same mechanism. What we have to do? We have to remove water, right? Then what we will get? Guess the name. This is hydrazine, this is hydrazone. Tell me, guess. Phenyl hydrazone. Sometimes names also will come. So write the product RCH double bond N NH phenyl hydrazone. Phenyl hydrazone. Clear? Next very important reaction with the 2,4-DNP or Brady's reagent. 2,4-DNP, another name is Brady's reagent. The reaction with the 2,4-DNP, dinitrophenyl hydrogen. DNP stands for dinitrophenyl hydrogen. 2,4-dinitrophenyl hydrogen, also called as Brady's reagent. Brady's reagent. Let us see this. I am taking another slide. You know, this is phenyl hydrogen. Now give the numbering for this phenyl ring. 1, 2, 3, 4, 5, 6. At second position and fourth position, two nitro groups are there. Clear? 2,4-dinitrophenyl hydrazine. 2,4-dinitrophenyl hydrazine, commonly abbreviated as 2,4-DNP. 2,4-dinitrophenyl hydrazine, commonly abbreviated as 2,4-DNP. What is the product? Remove water molecule minus H2O. 2,4-dinitrophenyl hydrazone. Attach these two. So I am writing just name only. 2,4-dinitrophenyl hydrazone. Structure, you know how to draw the structure, right? Next, reaction with semi-carbazide. Reaction with the semi-carbazide. This is also very similar to that. RCH double bond O. You have to remember this. Clear? This is semi-carbazide. This is also important. Semi-carbazide. Remove water. Minus H2. What you will get? Semi-carbazone. Semi-carbazide. Semi-carbazone. Here, these are addition followed by elimination reactions. All these are addition followed by elimination reactions. Clear? Let us start named reactions. Aldol condensation is given, na? Aldol condensation with mechanisms, right? Given or not? Aldol condensation with mechanism, right? Kenijaro reaction mechanism is not given, so important. Let us see. Yeah. What is the definition of Kenijaro reaction? First of all, let us understand. See, aldehydes without alpha hydrogen, very important, and the definition also questions will come. That is the importance of named reactions. Aldehydes without alpha hydrogen, in the presence of concentrated base like NaOH or KOH, concentrated NaOH or KOH, undergo disproportionation to give RCOONA, sodium salt of carboxylic acid, and alcohol, right? So first of all, observe the definition. I mentioned one point: aldehydes without alpha hydrogen. Means, tell me, without alpha hydrogen. Look at this. Formaldehyde, names also very important. Formaldehyde also called as methanol or formaldehyde. Right? Benzaldehyde. All these are not having alpha hydrogens, right? You know alpha hydrogen. How to check alpha hydrogen? Benzaldehyde. See, once I will give you a small example to identify alpha hydrogen. I am taking acetaldehyde. This is functional group. The carbon which is next to functional group is called alpha carbon, and hydrogen present on that carbon is called as alpha hydrogen. But for Kenijaro reaction, we need aldehydes without alpha. That is the condition. Now I am taking this example, third one. Will this undergo? Why? Because no alpha hydrogen. This can be written like this. What is its name? Give its name. 1, 2, 3. What is its name? IUPAC name? Can you give its IUPAC name? 2,2 dimethyl. How many carbons are present? 1, 2, 3. Propanol. 2,2-dimethyl propanol. Okay. Next, another exceptional case is there. Even though it is not having alpha hydrogens, it do not undergo Kenijaro reaction because strong minus I groups are present, so its nucleophilicity will be less. CCl3CH. Okay. Let us see the mechanism. Mechanism is very, very important. Okay. I am taking formaldehyde, concentrated NaOH. See first, one aldehyde converted to sodium salt, another aldehyde converted to alcohol. Observe the mechanism carefully. Step 1. First I am taking one molecule. Here I took two molecules, right? Two molecules. So I am taking only one molecule. And adding OH minus. What is the source of OH minus? NaOH. Right. This negative charge attaches to carbon. At that time, this pi bond will shift towards oxygen or shifts onto oxygen. To give H, C, O negative, OH and H. Okay. See step 1. In step 1, OH minus nucleophile adds to carbon. At that time, this pi bond will shift onto the oxygen atom. Right. Now, this negative charge will shift in between these two as a bond. At the time, hydrogen will leaves as H minus to give HC double bond OH. Carboxylic acid is formed, but due to basic conditions, it will exist in the salt. I given HCOONA, or you can keep as it is. But important point is H minus also forming hydride ion. Its name is hydride ion. Hydride ion is also forming. Very, very important. Hydride ion is forming. Okay. Clear? Any doubt in this? This negative charge is shifted in between oxygen and carbon and converted into bond. That's why I wrote bond, double bond here. Clear? Previously one bond is there. Negative charge is shifting in between that. And hydrogen leaves as H minus. Okay. Right. This is step 1. Tell this one. This negative charge is shifted in between these two. Okay. As a bond. Then H will leave like this along with bond, because around carbon only 4 bonds should be present, right? If hydrogen do not leave, then carbon will get 5 bonds. 5 bonds are not possible. H negative. Right. This is about step 1. Step 2. Step 2 is very, very important. That is the rate determining step. Step 2 is the rate determining step. Initially we took 2 aldehydes, right? 2 formaldehydes. One aldehyde is attacked by nucleophile. Right. Next I am taking another aldehyde. 2 aldehydes are there. I am taking second aldehyde. On the second aldehyde, the formed hydride ion will attack. This step is called hydride ion transfer. Very, very important. Hydride ion transfer takes place in which reaction? Kenijaro. Like this. Hydride ion. This is hydride ion. Okay. When this attaches to carbon, this bond will shift onto oxygen, because maximum bonds around carbon is 4 only. So we will get H, C, O negative, H and H. This is called as RDS, rate determining step. Slow step, very, very, very important. In Kenijaro reaction, hydride ion transfer, this question will come, remember, in the weekend exam. In Kenijaro reaction, which step is rate determining step? Hydride ion transfer is rate determining step. Clear? Right. Now, did we get alcohol? No. What we have to do? We have to do protonation. Proton transfer will give 3 hydrogens and 1 carbon, CH3 OH. Right. So, carboxylic acid or salt of carboxylic acid and alcohol is formed. This is about a mechanism of Kenizaro reaction. Kenizaro reaction. Right? Any doubt in this? You have to do practice. You have to do practice, right? Listening only not sufficient. You should do the practice also. Clear? Right. Now you tell me how many aldehydes we took? How many aldehydes we took here? 2. The same aldehydes or different aldehydes? Same only. If I take different aldehydes, then which aldehyde will convert to acid and which aldehyde will convert to alcohol? Very, very important question. Next level question in the Kenizaro reaction. See, very, very important example. When I take benzaldehyde and formaldehyde, I need 2 aldehydes without alpha hydrogen, right? That's why I am taking 2. Clear? Right. And if I add concentrated NaOH, then benzaldehyde will convert to benzyl alcohol. Formaldehyde will convert to acid, HCOONA. Why? Why we are not getting benzoic acid or sodium salt of benzoic acid? Why we are not getting methanol? This is very, very important example of Kenizaro reaction. When we take 2 different aldehydes in the Kenizaro reaction, both are not having alpha hydrogens. Both are not having alpha hydrogens. So both will participate in the Kenizaro reaction. But how to decide which aldehyde will convert to acid and which aldehyde will convert to alcohol? I'll tell you one simple trick. See, here we are taking base concentrated NaOH, right? From that OH minus will comes out, nucleophile. Remember, if this nucleophile attacks this aldehyde, this will convert to acid. If this nucleophile attacks this aldehyde, this will convert to acid. That is very, very important point. The aldehyde which is being attacked by OH minus will convert to acid. But how to know? How to know this OH minus attacks which aldehyde? Now we use resonance or inductive effect concepts. Clear? Right. What is the key point in the nucleophilic addition reaction? What is the key point? Presence of large positive charge. In the last class we discussed. Presence of a large positive charge is the key step, right? If large positive is present on the carbonyl carbon, then OH minus will attack easily. Clear? Let us start the discussion. I'll give that statement also under note. The aldehyde which is attacked by OH minus will convert to acid. Right. Look at this. I am taking formaldehyde and I am taking benzaldehyde. You only tell me the difference between these two. This is benzaldehyde. I'm highlighting one point here. What you observed, you tell me. What you observed here? Very good. More positive and less positive. Why here less positive is present? Why here more positive is present? Resonance. Because of resonance, this positive charge is nullified, reduced. This pi bond will enter into resonance. This pi bond will shift to this side. This is positively charged carbon. Double bond is present adjacent only. So resonance takes place. Shifting of pi bond will take place. So positive charge density decreases. Magnitude of the positive charge decreases. If positive charge is less, then how OH minus will attack? First, no. Clear. But in case of formaldehyde, large positive is present. So first OH minus attacks formaldehyde preferentially. What is the sentence here? The aldehyde which is being attacked by OH minus will convert to acid. That's why formaldehyde is converting into acid. And this will convert to alcohol. Very, very important example. Clear in the Cannizzaro reaction. Clear? Both of you. Right. Now I'll give you another example to you. Concentrated NaOH. This is internal Cannizzaro reaction. Any aldehyde you can convert because both are same only, right? This is one example. This is another example. CHO, concentrated NaOH, same here. One aldehyde converted to acid, CH2OH. Clear? This is another example. Got it, all of you? Right. What is Itard oxidation? What is Itard oxidation? What is Itard oxidation? Aldehyde. Which aldehyde? What is its name? Benzaldehyde. You are not preparing well. Toluene when treated with the CrO2 Cl2 in the presence of carbon disulfide H3O plus. First we will get a benzaldehyde. This when treated with the concentrated NaOH, what we will get a sodium salt of benzoic acid plus benzyl alcohol. Conversion type questions. Actually, you will get conversion type questions instead of direct questions. This is Cannizzaro reaction. Up to this part, Cannizzaro reaction. But see, conversion. Itard is covered and Cannizzaro also covered. Conversions are very, very important for us. Clear? We should focus on conversions. So many reactions are there to get benzaldehyde. You prepared already. Gutterman-Koch reaction, Gutterman-aldehyde reaction, conversions like this. For example, CO plus HCl, AlCl3. We'll get benzaldehyde. Benzaldehyde to again benzoic acid and benzyl alcohol. This is Gutterman-Koch. Right. Gutterman-aldehyde, HCN plus HCl, HCN plus HCl, like that. So conversions are also important. We should focus on the conversions also. Clear? Right. Okay. We'll continue tomorrow. Bye.